Hey everyone, good morning. How's it going? Thanks for coming out. I'm Iman Alvani. I'm joined by Brad Wheeler today. We're IBM Watson Health, and here briefly, Brad is going to show us some cool tricks and tips on how to fine-tune your Tableau dashboards for quicker load times and rapid performance. But before we get started on that, we want to kind of give you guys like a brief background, first for myself as well as Brad, and then also share Watson Health's Tableau story with you guys. So I've been in the business analyses world for about 10 years now. I started with Tableau about 2 years ago in 2017 when Brad came over. And then as far as Brad goes, so he's been in the healthcare technology realm for about 17 years now. He's dabbled in Tableau for about 6 years now. And then, so quick overview on Watson Health's legacy environment. So this is how we started out. So, we had one single source for reporting, and it was obviously SQL Server. You had the SQL extracts going behind the scenes for the macro-enabled workbooks in Excel. And then as you can see, each of our clients would receive an Excel report which was uploaded to the web portals, and those were on a monthly basis. So again, the data, keep in mind, was static, and so it was monthly. As far as our new environment, powered by Tableau, so now we have online dashboards. Those go to our own server landing page, so clients have logins to the portal, and then those data sets, those data extracts are refreshed nightly in lieu of monthly. So again, you have access to almost real-time data, right? And then just some quick snapshots of what our Tableau dashboards currently look like. And then we'll go over to a quick before and after as well. So again, this is something, this is like a quick screen grab of what our report looked like in Excel. As you can see, you had the filters, you had definitions. We used buttons to go back and forth between those pages. You had also a lot of the real estate was used for filters, and so you'll notice that even the pivot chart has its own filters. And then we come to the after. So once we started using Tableau for some of our reports, you'll quickly notice some of the difference, some of the key takeaways here. Again, much of the emphasis is on the visuals rather than the text. The audience can quickly look at key takeaways instead of having to filter and whatnot. Speaking of filters, our filters are now tucked away in a collapsible filter, so like not all of it is on the screen, and so I have the option to filter, expand, and minimize and so forth. And then also you can also add other stuff like icon buttons and whatnot if you want to store tooltips, which is the last one. So a lot of the verbiage can again go on the tooltips. User hovers over that and gets a quick idea of what they're looking at. So what happened after 1 year of Tableau? So 95% of all of our client reports are automated now and delivered via Tableau. And I won't go through all of these points, but you'll notice like some of the highlights. Our dedicated client reporting staff, we were able to take that and reduce that almost 76%, so 13 to 3. And then what that means is we're freeing up some time for the analysts to look at some other stuff, look at some other advanced research and analyses for value add. And then also wanted to share some of the stats that pertain to what Brad will be speaking to. Fast loading dashboards are critical. 5.3 second average dashboard load time is what we're at currently. 93% of all those dashboards load in under 10 seconds. So with that, I'm going to turn it over to Brad Wheeler, and he's going to go over the user recording performance.
Thanks, Iman. So yeah, we thought it would be helpful just for you guys to have a little bit of context as far as what our environment looks like. But as Iman mentioned, we work with very large data sets. They can get, the largest data set we've had was close to 1 billion rows. It was about 900 million rows worth of data. So when working with something of that large, obviously the dashboard load times can be quite slow. One of the most common recommendations that we get is, well, don't don't use row-level data. Instead, do all of your pre-aggregations in SQL so that you can, instead of having 900 million rows, or just call it a billion rows, you're doing all your pre-aggregation outside of Tableau, and now you're working with a much smaller data set, maybe 1 million rows or something like that. But we try our best not to go that route, because it really limits our functionality of our dashboards. So whenever you do pre-aggregation, that a lot of times just leaves the end user with just a number. They're not able to drill down into that number. It limits a lot of the functionality as far as filtering, dashboard interactions, and it also limits the reusability of that data set. One thing that we really try to do is to reduce the number of data sources that are utilized by our dashboard. So if we can have, quote, one single source of truth, I say one because there's different data sources for different things, but we strive to have one single source of truth, and if that one data source is pre-aggregated, then it kind of limits our functionality for reusing that data source for other dashboards. So we like to have our data be row level, not pre-aggregated, but the cost of that can sometimes be dashboard performance. So we've gotten quite good at figuring out, taking slow loading dashboards and working with them to figure out what can we do to make them faster without pre-aggregating our data. So some of the things that I'm going to show you today, at the end of the day, the message is going to be that there's typically not one silver bullet. I can't just sit here and say, if you do X, Y, and Z, your dashboards are going to be fast. Rather than trying to give you a punch list, I'm instead going to walk you through the process of how you can look at a dashboard that's running slowly, and what kind of process can you go through to get it to perform faster for you. So the first thing is just knowing how to use Performance Recorder. That is absolutely critical. So from Tableau Desktop, you take a dashboard that you want to work with, just click Help, Settings and Performance, Start Performance Recording, then load that dashboard. So typically, what I would do is something like limit the data so that it's just pulling something really small back, hit this Start Performance Recorder, and then Show All. And then that way it doesn't give me the full refresh time. And then I would go ahead and stop it after that. So I'm just focused on that one thing. Now, of course, you can let Performance Recorder run for a long time. And then once you hit stop, it's going to give you a whole string of things. And that's fine if you want to just kind of interact with it. But typically, I would just focus on one thing at a time. So I'm going to look at one dashboard. I'm going to run Performance Recorder on it, hit start, load it, and stop it. And then that way I can just focus on that. So when those come back, it's just it opens up a new Tableau workbook. And it's going to show us, it's going to be sorted by workbook, by dashboard, and then activity that happens in here. So up here we see all of the events that occurred, and they're sorted chronologically. Then you have the events sorted by how long they took to execute. And then if you click on any of these, you'll actually see the query underneath that that's being run behind the scenes. Now, this is not SQL. This is Tableau's version of SQL. It's a bit hard to understand. I really haven't gotten into that, but the cool thing is you may not have to. But you can see that if you feel like taking that and digging further. Now, it's pretty cool that is actually just a Tableau workbook, so it's completely editable. So for example, this is the default, this is the original performance recording over here on the left that's, looks exactly like I just showed you, but maybe you want to customize that to rearrange things and add some data labels and sort things in a different order. For example, this one over here is sorted, I'm not sure exactly how, but this is just a different version of that. You absolutely don't have to do that, but it is just a Tableau workbook. You can do whatever you want with it. Okay, so I'm going to walk you through 3 very specific examples. So again, this is not going to be, these answers here for each of these examples may not fit your use case, but that's okay. The process is what's important. So I realize this is blurred. you don't need glasses. This is just this is sensitive information, so we just had to kind of blur it out. The important part is not what's on the screen necessarily, but I will kind of just give you an idea. So this dashboard has some key metrics across the top here. It has it has a lot of filters over here on the right. Then we have this is a top conditions chart, and this is being limited to show, I think, top 10 things. Then we have a map, and then a little tree map down here. Now, this has, over here on the right, there's a parameter that allows the user to decide, do I want to view these totals by dollar or by patients? So that's going to become a bit important a little bit later. So that does let the user kind of toggle back and forth there. So when this was sent over to us, the original load time was 49 seconds. We try to keep everything under 10. So that's going to be a big challenge for us to get that to go down. So let's take a look at it. So we're going to run the performance recorder, and we can immediately see we have one long query being executed right here. When we hover over that query, we see that it's executing query. The dashboard is medical conditions overview, and the data source name, and the worksheet. So let's take a look at that. So when we look at that, this is an extract. We will get into the live connections versus extract in example 3. This is an extract. Okay, so in the original, we saw there were a whole lot of filters over there on the right. So whenever performance tuning, it's always a good idea just to kind of check those filters. There could be something there. So just as a quick test, let's go ahead and remove most of those filters. We're going to keep the data source action here, just because that's how the users toggle back, have the interactivity. We're going to go ahead and keep this one just so we can force a refresh. And we're going to go ahead and keep limiting the data to the top 10 rows. And then we're going to run performance recorder again. That made very, very little difference. It only reduced our load time by 2 seconds. So that was definitely not the problem. So we'll go ahead and add those back and undo that change. So now let's take a closer look at our detail shelf here. So I see here that, I know this is a bit hard to see, but we do have a field here called C, which indicates a calculated field in our instance here, for sort measure name. And that's on the detail shelf. So let's see what happens when we take that one field off. We took that one field off, refreshed it, and that dropped us from 49 seconds to 34. So that's a pretty good savings. But what happens when we take that off is we have a title here. Now it says top 10 conditions by none, because it's missing that field that we dragged off. So how can we solve for that? Well, the only reason that field was being used was for the title. It wasn't used for anything else. So what if we made another sheet that just had the title in it? Let's just go ahead and say top 10 conditions by, go ahead and put that field here. This is exactly what it used to be. It's just now, instead of it being on the title of this particular worksheet, it's now its own sheet. And then in our dashboard, we're going to hide the title of the original, put the new sheet we just created as the title. So to the end user, they cannot tell the difference, but we've just saved 13 seconds. So now we also see that one of those filters that I kept earlier was to limit the results to top 10. This is C top N is true. And we take a look at that. So what that's doing is it's using a calculated field that says the measure rank is less than or equal to the parameter of top N, which in this case is 10. What is measure rank? It's doing a rank unique of the sort measure. So we can accomplish the exact same thing by using a set rather than a calculated field. So what we're going to do is we're going to right-click on the field, and we're going to say the top, and then we're going to use that parameter, P top N, and we're going to sort that by the sort measure. And then we're going to filter on this set rather than on that calculated field. Now, whenever you filter by a set, the default method for that is for it to use all values. If you right-click on that and use in out rather than all values, that'll help a bit. So we're going to change that to in. So now doing that, we check our results. I know it's blurred, but trust me, they're exactly the same. Nothing is any different. And now we've dropped by another 19 seconds. So we've gone, we were at 49, now we're down to just 19. So that's a huge savings. Now that one query is no longer our longest running query, and now we see that it's now the geo, which is the map. So yeah, so the question was, is this because the data was cached? That's a great question. So what you'll want to do is you'll right-click on your data source and hit refresh, and that clears the cache. So the question is, what has changed in the background of Tableau? Now, you could go look at those queries, so we could click on this and see that query underneath and kind of dig deeper. I did not do that, because at this point, I don't care. It's faster. That was the end of it for me. But yeah, if you're really interested in what's happening behind the scenes, that query is there. So what you can do is you would click right here on this query, and then it pops up beneath it and actually gives you the behind-the-scenes stuff. So when we go in, now let's move on and go ahead and look at the map next. So when we look at the map, we see it's doing the exact same thing. So it's also it's the same problems of where it has on the C metric name in the detail shelf. So I'm not going to walk you through those steps, but we're just going to do it again. And when we do that, that drops from 24 seconds down to 10. So now let's see if there's still a little bit of room for more improvement. So we're still running at about close to 18 seconds. So in looking at this, I notice that there's another calculated field. Now, whenever you're doing calculations, if you'll prefix them with a C or something, that would help you identify things like this, because you could say, oh, this is a calculated field. It may be a problem. Typically, calculated fields work great. But if you know something's slow, those are good places to look. So we do have a calculated field in our label. So let's take a look at that. What this field is doing, the sole purpose of it is to show or hide a dollar symbol. Because if you remember, the user can toggle between cost and patience. So on our label, on our chart here, if they pick cost, we want this label to have a dollar sign. If they don't pick cost, we don't want it to have a dollar sign. And that's being used right here in the label. So that's it. That's all it's doing. Now, if we take that out, that actually saved us a bit of time. I don't know why I went a little bit out of order, but it does save us some time. So what we're going to do instead of that is let's make 2 fields. So we're going to create 2 label fields. One of them is we're just going to say if the parameter is cost, then give me the cost. Otherwise, give me nothing. It's going to return a null. And then our other one is going to be for patience. If the person picked patience, give us the patience. So we have 2 fields. They'll return null if the other one's not picked. Then we're going to set the default value for that. So when the person on cost, we're going to default that to have a dollar symbol. When they pick patience, we're not going to have a dollar symbol. Then we're going to put both of those fields in the data label. That saved us 6 seconds. So now we look at our original. We were at 49 seconds. We were able to get it down to 12 without aggregating our data, without changing anything from the end user's perspective. So how did we get there? 49 seconds, we shaved off 15 with our top conditions detail shelf, another 10 by using a set, another 6 by doing the same thing for the map, and another 6 by using the custom data labels. So that got us down to 12. So 76% reduction in time. So again, none of those may apply to you, but it's just the process of how you got there. Okay, another example. So this one was a beast. This sucker was running for over 2 minutes. This one was quite a bit of a challenge. So first problem, when we look at this, we run the performance recorder on it. We see this one top query right here, this one section that I'm kind of highlighting here, was taking 81 seconds to run, and then another 33 seconds to sort the data. And you can tell that's what's happening here because it's out of order. Now, when we go back up here, I'm going to scroll back up. So in looking at a query, this is fairly normal when you see these things that are happening in order like this. And then you see this other little tiny thing here at the end. What that is that's sorting the data. This is pretty normal. You're going to see this little thing happening at the end to pre-sort the data. If you ever have a default action or default sort order, it's going to run and return the data. Then it's going to sort the data. And this has to query to figure out what order do we want to sort it in. So this thing running for 33 seconds just to simply sort the data, probably not worth it. If we take off that, so let's take a look at that field. This modality combination is being sorted by a field called patient response rate. So when we look at patient response rate, what is that? It's a calculated field that consists of two other calculated fields, both of them doing count distinct. So count distincts are always going to be slow. They're going to be one of the slower functions because it has to do a string comparison on the entire data set to figure out what's unique about them. So what if we don't sort? Does that really make that much of a difference to the end user? This is a pretty small data set that's being returned. Again, it's blurred so you can't really tell, but you can sort of tell. The data looks pretty much the same, and we can save 33 seconds of the load time by just not sorting it by default. So let's go ahead and take the easy way out there and not sort that. But it's still taking, so now when we run the thing, we see, okay, now there's no longer that extra little tail at the end that's running. So that's good. So let's move on. So then we look at this one. This one gets a bit more interesting because I admit we kind of cheated on that one. We just said, let's just not do that. But we can't necessarily do that on this one. So when we take a look at this view, what this is doing is it's filtering the data on a calculated field called modality combination phone, and it just looks for phone. It won't show it if it's null. Okay? What is that calculation? It's a calculated field that says if the modality combinations contain phone, then say phone, otherwise null. This modality combinations is made up of a fairly complicated calculated field that just looks to see at the patient level, have they ever received a phone call? Have they ever received an email? Have they ever received a text? And it concatenates all those together. So our business is engaging patients. So we can reach out to you by phone or by email or by text message or a combination of those. So we want to know for anyone that we've ever tried to reach by phone in any way possible, how successful are we in reaching that patient? So we have a calculation like this. Now, if we remove that filter, we immediately save 14 seconds because that filter is fairly complex. Not the magic bullet, but 14 seconds is still a decent savings. But the problem is now we have these extra columns that we don't need. But the cool thing about Tableau is filtering the data is not the only way to hide what you don't want to see. So if instead of filtering the data, if we just right-click on the column here and say hide, then it goes away. So we can hide all the ones we don't want to see. It ends up looking, oh, here we go, right-click, hide. It ends up looking exactly the same to the end user, but it has saved us 14 seconds. As a quick tip, if you ever want to get them back, you can right-click and say show all, kind of like in Excel. So that saved us a bit. But now let's dig deeper into that calculated field. So as I described a second ago, what we're looking to see is by patient, have they ever received a phone call, an email, or a text? So this is what this formula returns. So it returns email, email, comma, text, phone, phone, comma, email, phone, da-da-da-da. So it's all the different possible combinations that can be retrieved. Now this is doing, again, a fairly complicated level of level of detail calculations that are looking for strings. That can be slow. So what if we used math instead? What if we said if we reach to the patient by phone, assign that a value of 1. If we reached out by email, assign that a value of 5. And if we sent them a text, assign that a value of 10. The values don't really matter. They could be 100, it could be 1,000. It doesn't really matter. It's just a unique thing. And then let's add that up by patient. So we get the numbers of 1, 5, 6, 10, 11, 15, and 16. So if we look at this, if phone equals 1, and our result is 1, when we added them all up for that patient, that means that patient only ever received a phone call, and that's it. If we get as a different example, we have a value of 16. How can they possibly get a 16? There's only one way. They had to have been a 1 plus a 5 plus a 10. That equals 16. So by doing that, that dropped us from 82 seconds to 27 seconds. Huge savings. But now we have the numbers 1, 10, 11, 15. Nobody knows what the heck that means. But that's cool. All we have to do is right-click, edit our aliases, and instead change the 1 to phone only, 2 to text only, and so forth. So we're just going to change what the end user is seeing on the screen. So now we end up with, when we can go back and compare it, the dashboards look exactly the same. The only difference is we're not doing this sorting up here. But other than that, it's exactly the same. And we've gone from over 2 minutes to about 42 seconds. Still pretty slow, but heck of a lot faster. So again, how do we get there? No default sorting. Hiding versus filtering saved us a bit. But the big winner here was using math instead of string comparisons. So that's, again, about a 70% reduction in load time. OK, last example. So not all of them are super slow. Sometimes we get dashboards that aren't so bad. So this one, 21 seconds. Our goal is for it to be under 10. This one's not terrible, but we think we can do better. So this was one that was sent over to our team to say, can we make this faster? So we took a look at it and immediately ran our performance recorder on it, and we saw that everything is returning fairly fast. Our longest running query was 7 seconds. Nothing really stood out as being super slow, but there's a lot going on. We've got a ton of queries happening. But we also noticed that it was using a live connection. So step 1, easy fix. Let's just change that to an extract. So we just right-click on that, extract the data, publish that up to the extract to our Tableau server, and just set the refresh schedule to whatever makes sense. Most of the time, you can refresh daily. Sometimes you can refresh weekly. Sometimes you have people that say, I want my data to be really, really live. You can refresh as frequently as every 15 minutes. So that's, if every 15 minutes isn't quite good enough, then sometimes you just have to live with the slower performance. But most of the time, people are reasonable. If you tell them, hey, I can save you 50% off, I can shave 50% off your load time if you just let me refresh this every whatever versus then it being live. So most of the time, business users are OK with that. So that dropped us, basically cut it in half. Took us down to 13 seconds. So that's cool. We're getting close to that goal. But we also see there's a ton of queries still being ran. We're still running 32 queries, which is a lot for one dashboard. And you can see that it starts to stagger out. Most of the time, these will run is sequential. These will run at the same time. But when you have so much happening, they start to stagger out. And so that's what kind of adds these up. So even though our slowest query is only 4 seconds, our total load time is 13 because there's just so much happening. So let's take a look at this dashboard. This was this is a dashboard that was created by, the design was laid out by a design person, a marketing person, not an engineer. They said, OK, we want to have this metric shown here. We want to have a key metric value over here on the right, and we want to have a label underneath that describes it. Well, whenever you have these labels that the designer had put in between here, that forces you to have to break these out into separate dashboards. There wasn't really any way around it. And then these numbers that they wanted over here, there wasn't really a way to get them over here without making a separate sheet for it. So again, the person who designed it wasn't really thinking about from a performance standpoint. They just kind of put it together on paper. So the person who created the dashboard just designed it to fit exactly that, and that's perfectly fine most of the time. But then when we come back to look at it from a performance standpoint, basically we said, okay, what if we just redesign this a little bit so we don't have to require 25 different sheets? Because if you think about that, not only is your performance faster, your maintenance going forward, if you ever want to make a change, can be kind of a nightmare. So we were able to go back and redesign it, and since it's kind of grayed out, it's a bit hard for you to see, and I get that, but basically just trust me, and that it was just a matter of working with the design team to say, hey, what if we went this design instead? This is going to really help your performance, and there's some other benefits to it as well. So basically what we ended up with was just having 6 sheets instead of 25. I apologize for not being able to show that, but it's just one of those things. So basically what we were able to do is we were able to take that number of queries being executed from 32 all the way down to 11, and we were able to get our total load time to about a little under 7 seconds, so pretty good. Now you'll notice one other thing here that was going to save us a little bit of time. This is using a calculated field to filter. And as you guys can probably noticing a trend here, anytime we see calculated fields, we want to take a closer look. So this calculated field, it just simply says, if the code type is C, then show system. Otherwise, show facility. OK, easy enough. That makes perfect sense from a display standpoint. If you're seeing it on the screen, you don't want your end user to see C and not know what that means. But from a filtering standpoint, us behind the scenes, we can just filter on C. We don't have to use this calculated field. So let's just, from a filtering standpoint, let's filter on this code type field of just equaling C. And doing that would save us about another 1.2 seconds. So not the biggest deal ever, but still. When you're talking something that's already pretty fast, shaving off another 1 second didn't hurt, definitely didn't hurt. So we took it from 21 seconds by shaving off about 8 by going to an extract, another 7 by doing a dashboard redesign, and another 1 by simplifying our filter logic to use our standard field rather than a calculated field. So that, again, results in about a 76% reduction in time. So those 3 examples are hopefully will just kind of give you an idea of the process of how to kind of go through there. So we do, actually I'm going to skip ahead just a bit. So just a few general performance guidelines. So extracts generally perform 30 to 40, sometimes 50 or 60% faster. So if you can go that route, it's good. Count distincts are going to be notoriously slow. If you reach out to Tableau and you say, I'm having a really hard time with this function, it's super slow, it's a count distinct, they're going to tell you, yeah, count distincts are slow. There's nothing you can really do about it aside from changing your data structure. Using calculated fields and filters can cause slow performance, so filter on the native fields whenever possible. And reducing the number of queries. So I'm not going to go through all of them, but I just wanted to kind of recap on those. So how do we at IBM Watson Health know which dashboards need our attention? Obviously, you can wait for people to complain. That always works. Or you can be a little more proactive about it. So there are default Tableau server performance reports that are available for your admins. So if you go into status, stats for load times, you can see what your load times look like. And you can say, okay, these look slow, and let's drill into these a bit more. We found those to be not super helpful. We thought we could do it a bit better. So we went ahead and opened up access to the Tableau repository. The Tableau database repository is stored in Postgres. If you Google it, access to Tableau Postgres or access to Tableau database repository, every single thing that Tableau server does is logged in their database, in their Postgres database. So every time a user clicks a button, that gets logged to the database. Every time a page is loaded, every extract that runs, everything that happens on Tableau server is logged in the database. So it's extremely simple to open that up. You just have to have your admin enter one really simple command, and now that becomes available for you as a database that you can connect to in Tableau. So then you can use that to say, okay, let's build our own dashboards that are going to be used to monitor our server performance. So we created our own, so we can say, what's our average load time looks like, what's our distribution, so what percentage of our pages are loading in under 10 seconds or 10 to 19 seconds. What does that look like by week, by day, all that sort of cool stuff. What are our totals by project, by user, by workbook, by view, so that'll quickly bring things to the top if you want to go out and actively look at it. So that's all good stuff if you want to actively look at it. You can also put them up on TVs. We've got some TVs around the office that we can see in real time. Hey, who's logged in right now? What are the last few things that were pulled up? And so that's something that you could kind of do as well. But one of the things that I like best, actually, is getting email alerts. So we created a dashboard that just simply says, yesterday, what were all the dashboards that took over 10 seconds to load? And then we set up an alert on that. So anytime at least one record is returned, send an email to the team. So that way, we may not always pay attention to it. It might just be like, OK, well, that was one time, one off. But if you start getting those emails over and over again, it's like, oh my gosh, this thing's taken forever. That's a really nice way so that you don't have to wait for people to complain, for you to know and be alerted as far as what are some different things you can look at. So the most important thing is performance tuning is more of an art than a science, and that's for sure. If you reach out to Tableau and you say, hey, I'm having a hard time with this dashboard, what are some things that can help? They're going to tell you things like what I have here, check your filters, that kind of thing. But at the end of the day, it really takes experimenting, creativity, and troubleshooting, and just a lot of patience to work through these things. So hopefully this was helpful for you guys, and understanding the process of working through that and how you can troubleshoot some of your slow performing dashboards. So I hope it was helpful. If you'd like to come up and talk to Aman or I, feel free to do so. I think we have a little bit of time, so feel free and fill out the survey if you don't mind. Thanks, you guys. Have a good afternoon.